Hey guys, so today I'm gonna to do my final presentations for my physics, cells, and molecule class, and my topic is the story of the galaxy, and I'm gonna to introduce our universe and some stars in our galaxy. The first one is the origin of the star, of the universe, and there is the Big Bang theory. The Big Bang theory is the leading explanation about how the universe began. At its simplest, it says the universe as we know it started with a small singularity, then inflated over the next 13.8 billion years to the cosmos that we know today. So here is the expansions of the universe model. And next, I'm gonna to introduce some stars in our galaxy. First one is red giant. The red giant stars have exhausted the supply of hydrogen in their core and switches to the thermonuclear fusion of hydrogen in a shell surrounding the core. So, the red giant is a luminous giant star of low or intermediate mass, and red giants are evolved from main sequence star. When the star exhausts the hydrogen fuel in its core, nuclear reaction can no longer continue, and so the core begins to contract due to its own gravity. This brings additional hydrogen into the zone where the temperature and pressure are adequate to cause fusion to rhythm in the shell surrounding the core, and the outer layer of the star has expanded greatly. So that's the red giant. So, what is the black hole? A black hole is a region in space where the pulling force of gravity is so strong that light is not able to escape. The strong gravity occurs because matter has been pressed into tiny space. This compression can take place at the end of star's life. Some black holes are results of dying stars. Because no light can escape, black holes are invisible. However, space telescopes with special instruments can help find black holes, and they can observe the behavior of material as stars are very close to black hole. So, how big are black holes? Black hole can come in a range of size, but there are three main types of black holes. The black hole's mass and size determine what kind it is. The smallest one is known as primordial black holes. Scientists believe this type of black hole is as small as single atom, but with the mass of large mountain. The most common type of medium-sized black hole is called stellar. The mass of stellar black hole can be up to 20 times greater than the mass of the Sun, and can fit inside a ball with a diameter of about 10 miles. Dozens of stellar mass black holes may exist with the Milky Way galaxy. And the largest black holes are called supermassive. These black holes have mass greater than 1 million suns combined and would fit inside a ball with a diameter about the size of the solar system. Scientific evidence suggests that every large galaxy contains a supermassive black hole at its center. So the supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A. It has a mass equal to about 4 million suns and would fit inside a ball with a diameter about the size of the Sun. And then, how do black holes form? Primordial black holes are thought to have formed in the early universe, soon after the Big Bang. Stellar black holes form when the center of very massive star collapses in upon itself. This collapse also causes the supernova, or exploding stars, that blast part of the star into space. Scientists think supermassive black hole forms at the same time as the galaxy they are in. The size of the supermassive black hole is related to size and mass of the galaxy it is in. So, If the black holes are black, how do scientists know they are there? A black hole cannot be seen because of the strong gravity that is pulling all of the light into a black hole center. However, scientists can see the effect of its strong gravity on the stars and gases around it. If a star is orbiting a center point in space, scientists can study the star's motion to find it if it is orbiting a black hole. When a black hole and a star orbiting close together, high energy light is produced, so scientists' instruments can see the high energy light. A black hole gravity can sometimes be strong enough to pull off the outer gases of the star and grow a disk around itself called a accretion disk. As gas from the accretion disk spiral into a black hole, the gas heat to very high temperature and release X-ray light in all directions. NASA telescopes measure the X-ray light. Astronomers use the information to learn more about the properties of black hole. The next one I'm going to introduce the neutron star. When the core of massive star undergoes gravitational collapse at the end of its life, proton and electron are literally squashed together, leaving behind one of the nature's most wonder creations, neutron star. Neutron star crams roughly 1.3 to 2.5 solar masses into city-sized sphere, perhaps 20 kilometers across. Matter is packed so tightly that a sugar cube-sized amount of material would weigh more than 1 billion tons, about the same amount as Mount Everest. So, what is the supernova? A supernova is the explosion of a star. It is the largest explosion that takes place in space. So, what causes supernova? A supernova happens where there is a change in the core or center of a star. A change can occur in two different ways, with both resulting in a supernova. The first type of supernova happens in a binary star system. The binary stars are two stars or orbit that same point. One of the stars, a carbon-oxygen white dwarf, steals matter from its companion star. Eventually, the white dwarf accumulates too much matter. Having too much matter causes the star to explode, resulting in a supernova. The second type of supernova occurs at the end of a single star's lifetime. As the stars run out of nuclear fuel, some of its mass flows into this core. Eventually, the core is so heavy that it cannot withstand its own gravity force. The core collapses, which results in the giant explosion of a supernova. The sign is a single star, but it does not have enough mass to become a supernova. So, why do scientists study supernova? A supernova burns from only a short period of time, but it can tell scientists a lot of the universe. One can supernova has shown scientists that we live in an expanding universe, one that is growing at an ever-increased rate. Scientists also have determined that supernovas play a key role in distributing elements throughout the universe. When the star explodes, it shoots elements and debris into space. Many of the elements we find here on Earth are made in the core of stars. These elements travel on to form new stars, planets, and everything else in the universe. The white dwarf is also called degenerate dwarf. It's a stellar remnant composed most of electron-degenerate matter. A white dwarf is very dense, and white dwarfs are thought to be final evolution stars, a state-of-the-art stars whose mass is not high enough to become a neutron star. Over 97% of the stars in the Milky Way. After hydrogen fusing lifetime of main sequence stars of low or medium mass ends, it will expand to a right gas which focus helium to carbon and oxygen. It occurs by the triple alpha process. If a right gas has insufficient mass to generate this core, temperatures required to fuse carbon around 1 billion K, an inert mass of carbon and oxygen will build up at its center. After shedding its outer layers to form a planetary nebula, it will leave behind this core, which forms the remnant white dwarf. Usually, therefore, white dwarfs are composed of carbon and oxygen. So let me introduce some of the units in the unit that the scientists use to measure the universe. A parsec is a unit of length used to measure the astronomically large distance to objects outside the solar system. 1 parsec is the distance at which one astronomical unit subtends an angle of 1 arcsecond. A parsec is equal to about 3.26 light years. In length, the nearest stars, Proxima Centauri, is about 1.3 parsec from the Sun. Most of the stars visible to naked eyes in the nighttime sky are with 500 parsecs of the Sun. And the next unit is light year, which we usually use to measure the length in the universe. And light year, sometimes written light year, is a unit of length used informally to express astronomical distance. It's approximately 9 trillion kilometers. And a light year is distance that light travel in vacuum in 1 Julian year. And that's all. Thank you. Bye.